section 2.2 today on the limit of a function. And I've got a graph here. It's kind of similar to one that we had in Zoom class the other day. I've got a hole punched in the graph, and we talked about evaluating function values at a point like that. We would say that f of 3 is undefined, or f of 3 does not exist. All right, that hole there in the graph is kind of a phantom point. It's not really there. When we go up and try to find the y coordinate, it doesn't exist. When we take the limit of a function, we get to pay homage to the fact that this function kind of looks like it's headed for a y coordinate of 1, even though it doesn't actually achieve that. When you talk about the limit of a function as you approach a value of x, you're just talking about what it looks like the y coordinate is going to be based on the behavior of the function at the nearby points right next to 3. All right, so you can kind of think of, if I take this line here and I kind of obscure what's actually happening at x equals 3. The limit says just ignore what's in that little gray chamber there and say, what does it look like? What does the nearby behavior of the graph tell you that f of 3 might be equal to? And that's where we get that value of 1. So we would say that the limit of f of x, the limit of f of x as x approaches 3 is 1. All right, so as you get close to x equals 3, the function is telling you that it's headed towards a y coordinate of 1. In this case, it doesn't actually achieve that y coordinate of 1. This is what we call the limit of the function as x approaches 3. All right, so we don't have to write this sentence every time when we're evaluating limits. We're just going to write the letters LIM for limit. Underneath the LIM, we write an x with a right arrow 3 and f of x. So we would read that exactly like the sentence. The limit of f of x as x approaches 3 is 1, so equals 1. And we don't just evaluate limits at holes in the graph. Those are the most interesting places to evaluate them. We can evaluate them anywhere. So if I kind of drag this limit veil over to another point, let's try over here at x equals 1. The limit asks you to ignore what happens at x equals 1 and say, look at x values that are really, really close to 1, just right next door to the right and to the left. What does it look like the y coordinate is going to be when you get to x equals 1? Well, in this case, it looks like I'm going to have a y coordinate of 3. In fact, I actually do, but we can also say that in terms of the limit. We can say that the limit as x approaches 1 of f of x is equal to 3. It happens to agree with the function value, but the limit doesn't care. The limit ignores what's happening at the particular x coordinate we're talking about and just says, what does it look like the y coordinate's going to be? And again, we can evaluate these limits at any x value that we want to. So we could take this limit bar, we could kind of scoot it over here and say, what happens to f of x as x approaches -1? So just look right next to -1 on the right and the left. The y coordinates look like they're heading towards 1. So we would say that the limit as x approaches -1 of f of x is equal to +1. Again, that also happens to agree with the function value. The limit doesn't really care whether the function exists there or whether it's a hole in the graph. Doesn't really matter. The limit just wants to know what does it appear like it's going to be equal to. So we're going to use this very strange looking function to make sure that we understand the difference between evaluating a function at a particular x coordinate and calculating the limit there. So this graph is posted on our Moodle page underneath the resources for the week if you want to take a look at it there or print it out. All right, so the first thing we're asked to calculate is f of 0. All right, so for f of 0, regular old algebra problem, we're going to go over to x equals 0 and say, what's the y coordinate of my function? And it looks like the y coordinate is 4. So f of 0 just equal to 4. All right. Now, when we calculate the limit, we're going to say we don't care what actually happens at x equals 0. We just want to say, what do the neighbor points tell us it looks like it's going to be? So I'm going to take that big line, kind of obscure what's actually going on at x equals 0, and say, what does it look like the y coordinate's going to be? And for this particular point, the answer ends up being the same as the function value. If you look just to the right and the left of 0, it looks like it's headed for a y coordinate of 4. So our limit as x approaches 0 of f of x is also equal to 4. All right, let's clean the graph off and move on to x equals 2. All right, so when we're evaluating f of 2, we're looking at 2, and the function value there, it's got a hole punched in it like our other graphs. We're going to say that f of 2 does not exist. So does not exist. But then when we take the limit of the function, that's where we cover up what's actually happening at x equals 2. And if you ignore what's happening actually at x equals 2, the y coordinates in the neighboring values are telling you that the y coordinate is headed for 0. So the limit as x approaches 2 of f of x is equal to 0. All right, let's move on to the most complicated part of this graph over at -1. All right, so when I'm evaluating f of -1, I'm going over at -1 and I'm saying, what's the y coordinate at -1? And remember that we're going to pass right through this phantom point, and we don't find anything of substance until we get to that point at y equals 5. So the function value is actually equal to 5. When we take the limit, we're going to cover up everything that's actually happening at -1. So I'm going to cover up what's going on here at -1. And if I cover that up, I get rid of that dot and the hole in the graph, and it just looks like this function is heading towards a y coordinate of 3. So the limit as x approaches -1 of f of x is equal to 3. All right, so the function values care what's actually happening at that number. The limits are just concerned with what's going on very, very close by to the number we're interested in.